doing everything. Fiddled around with Ruby and Rails a couple years before I started my apprenticeship, but mostly just been seeing.
Cool. Cool. Isaac, I just started this thing on that, so feel free to go ahead and get started, and you can introduce yourself as you're presenting.
Why is that so blurry?
There's exactly 10 pixels.
Can you change your display?
Yeah, working on it. Okay, here.
Change your actual display.
Oh, there we go. I changed it to 720.
Just keep it at 1080.
Oh, really?
Unless you need it giant.
No, I just thought you'd be able to read it easier.
Maybe that's just blurry.
Yeah, can we like maybe, just focus it?
Let's try this.
Something you can do that high resolution.
Seems like it was pretty clear last time.
Oh, yeah.
Is anyone doing a local
That's like a 320p.
Rails Girls thing anymore?
No, not that I know of.
That's where
We were going to do the Rails Bridge thing before we had last year, but didn't get organized, and this year hasn't really come up. We were talking about doing another conference before the so the day before kind of.
I think I did at least one other one, too.
Is it Chair O'Shea?
Nope.
Everybody look the other way real quick.
I don't work here.
Or commerce.
This is
That's potentially the one too.
That is,
What happened
yeah.
last time you stood in?
Someone else did one after that.
Unless you're taking it off the screen.
They had a real strong.
Sorry.
Tell me when it's
Oh, okay, yeah. Okay, it's pretty clear.
Yeah.
Maybe it could be a tiny bit more. I mean, yeah, that was perfect, but now it's not. That's closer to perfect.
It's very pixelated.
But it was real actually. Okay, just very, very slowly move toward focus.
Well, it doesn't move as smooth as you might.
Okay, yeah, I believe you. That's good. Stop.
That's good. That's good.
Okay, it went a bit past, but it should be good. Hopefully.
That's better than it was.
Yeah, I mean, we're pretty much just looking at bytes anyway, which looks like pixels, so
Yeah.
should be good.
Good enough.
This display is encrypted.
And even that. Yeah.
You need like a decryptor to like read this display.
Yeah.
That's all right. That's all right.
I have never heard of it.
Oh, yeah, that's not gonna work.
Okay.
Yeah. That's how many cans there are now.
Pretty much.
Is it targeted?
Because Ryan Bates quit. Yeah. Okay, so I'm Isaac Sloan. I work for Nikola Motor Company. I've used to work for other companies. I've been programming professionally since 2003, and I still more or less like it. I mean, you can get burned out occasionally, but it's a good career. And if anybody's good at like system programming or Linux kernel programming or CAN bus or Bluetooth, please hit me up. But that's not why I'm here. So I'm just talking about encryption, and also my favorite movie. I just saw Ready Player One, and it's pretty good. I mean, they messed up from the book a little bit, but
Yeah, you did read the book.
I did read the book.
Okay.
Yeah.
It's like completely different.
Well,
It's like, yeah, exactly. It's like chopped and screwed.
everything
Like,
in the Oasis
the
is
first key is like not even like
everything in the Oasis is different, but outside the
Yeah, like,
Oasis, it's about like 70% the same.
70% the same.
Outside the Oasis.
Oh yeah.
Inside, it's like 5% the same.
Yeah.
Anyway,
Just let Matt know when he can unplug his ears. That's all.
okay, you can unplug your ears. Okay, so hopefully you can read this. I kind of can. It looks better on my Retina displays if you just want to get around here. So basically, we're talking about encryption. We all use encryption. We all use SSL. We all, in our Nginx configs, tell it which types of ciphers to use, and we read whatever ones supposedly are the best ones now, and we use crappy ones, so IE7 still works or whatever. But few people have actually like dove really deep into why one works better than the other, what ones are faster, and in some ways, even what encryption is. So I'm going to be briefly covering all of those things. To start off, I'm going to just open up a new file and just call it like, I don't know. I'm going to do it in Crystal because bytes are easier in Crystal, but it mostly looks like Ruby. So let's see. So I already actually wrote it over here, but I'm just going to copy like a couple of things out of here and then explain what they are. Cool. So pretty much what I'm doing is I'm just requiring OpenSSL, since I mean that's what we're all using, and that's where most of the ciphers in the open source world like reside. I'm also requiring secure random just so I can get random bytes for like seeding things. This line we'll talk about later. So then right here I'm just passing in a file name so that I could possibly make this encrypt whatever file I wanted. And I'm exiting if we didn't pass in a file name. So ignore all of that. And down here, I am opening up the base file and getting all the bytes. Stupid Mac, man. Like Vim in Mac used to work just fine with copy and paste, but they changed that, and then they also made it so you can't install the homebrew version over it because it's in like a protected like part of like the operating system. Yeah, also nothing to do with this talk. So one thing about bitmap files is that the first 54 bytes are the headers that describe like what color space is this using, and you know, are you using 16 bits per color, or is it grayscale? At which point it would just literally be like you know, a single byte per color. In this case, I don't really care what it is. I just care that I don't want to encrypt those bytes because I want to be able to open this image up again. So I'm saving those off as headers right here. And let's put those there. So now from that base file, I've opened it up, turned it to bytes, and I pulled off the bytes that are the headers. And then everything else is the data, which I want to encrypt. So really fast, I'm just going to.
It's not 54 on line 15. It's the last. Never mind.
Yeah, sorry about that. Okay, so oh, that was not the one I wanted to close. Yay. But I'm going to close that one. Okay, so this right here, we have this opened up. So a really simple way to encrypt this would be take all of the bytes and then change those bytes in some way. The simplest encryptions you'd see. Yeah, so I mean, you could actually substitute every byte by like a certain amount. Like you could say like, you know, Zord against the same other byte or something, at which point it's a different byte than it used to be, but it's really easy to crack. I could demonstrate that by just writing, it's called def simple encrypt. And basically I'll take in data and I'll take in a secret. And I like cheating, I guess. So I'm picking data, I'm picking in the secret right here. And then inside of here, what I'm actually doing is I'm just mapping the entire array. It's technically a slice, but it's like an array of bytes. And then I'm just alternating over the secret. So if the secret was like 1 key, then right here, I'm just saying modulus the size against the size of the key. So if the key is like 5, then I'm going to just take the index and alternate through that. So every 5 characters, it's going to repeat. Does that make sense? Are there any questions as to like what the XOR operator does or why we're doing that?
So the XOR is the exclusive OR, right? So
yeah, so XOR, yeah, XOR, XOR
yeah.
is one or the other, but not both.
Okay.
That's extremely useful in binary because you could take a byte or any other length of binary and XOR that against something else, and then you could get the exact same value by XORing that key against it again.
Okay, so it's reflective or it's
yes.
Symmetrical.
Yes.
So if you put this back through the same way, then you're going to get the
yeah. So yes, I can actually decrypt it in the exact same way I'm encrypting it.
Right.
Pardon me?
With the same key.
Yes, with the exact same key. Yes. I mean that's so that's a really simple form of encryption. Here's my other one, but let me just actually run the simple one right here and demonstrate how that works. So in this case, we're creating a new file right here. We're writing the headers to the file, because those haven't changed. We're encrypting the data with this password right here. And then we're writing the file and we're closing the file. So let me go over here and I'll run encrypt cr. Oh yeah, I need to pass it a file name. So I'm just gonna pass it Ruby. Yes, sorry about that.
Way of hiding.
Yeah.
It's encrypting the view.
Under the file name. Yeah, that's good. Obfuscation through pixelation. Trademark. Okay, oh, there, file name. So, oh yeah, so I need this because I have raw file. I want to get okay, yeah. So, okay, cool. So now I have file name. I'm taking the raw file name. I'm taking the bitmap off because I don't care about that. I just want the name. And then, yeah. So now that should work. So back over here. Let's make sure this is big enough. Run that again. Here we have a Ruby bitmap. It should create another bitmap. So now let's open the Ruby one so you can see what that looked like. Looks like that. Maybe I can make that bigger too. Sort of. Okay, there. So we have pretty much what the Ruby logo looks like. So then if I were to go back over here, let's open up open Ruby simple. So that's with the simple encryption. Now, as you can see, it still kind of looks like a Ruby. If that was ASCII data, it would be completely unreadable to you, and it'd be really hard to figure out what it is. But presumably, some sort of machine learning algorithm or something else could see the similarities that hadn't changed as easily as you can see that, like, this is still a logo for Ruby. So that's actually just a really simple encryption format. We haven't really used anything that simple since Blowfish, or maybe even before. But let me just demonstrate one more thing with this simple encryption now, and that's what this line up here was for. So let me just say secret bytes equals, I'm gonna pass in like, I don't know, let's just say like 256. So that's gonna be a pretty long key right now. So if I come down here and instead of passing in the string right here, which isn't actually very secret, I could just pass in secret bytes and come back here and run again. So to run that, it's a way longer key this time. Let's open the same file. And you'll notice it's much harder to see what that is.
Run that through again and show it coming back out. Yeah, I'm wondering.
Because it's symmetrical, right? So it should decrypt it.
Oh yeah, yeah, I can totally decrypt it. If that's okay, yeah, I'll write one that decrypts it really fast. But let me just go one more layer deep into this thing. Like you can still see like there's a shape here, right, and not here.
Okay.
Yeah.
You
can almost feel like
the magic eye.
Yeah, magic eye.
I'm starting to go cross-eyed into it as
So I believe that that's 800 characters wide is like how many bytes it goes along. So, I mean, if I were to just go, I don't know, let's just say like 900. So there's pretty much nothing repetitive. You'll probably see like lines coming down now because it's going to overlap a tiny bit. You know, go back over here, run that again, and open simple, Groovy simple BMP. And okay, so now,
you can kind of see it more from Groovy.
yeah, so now you should honestly not see anything having to do with the actual pattern there. It's mostly just like an artificial pattern generated by the bytes that we're giving it. And like the more we go, I mean, the longer we make the secret, obviously it's going to be longer.
Zoom way small real quick.
Okay.
See the shape of it like in green.
Mm-hmm.
Yeah.
Oh, yeah.
It's kind of interesting.
Yeah, like you can still make out
Maybe
something.
I want that.
I mean, yeah, you can see there's kind of a line here. But if we were to make that longer and longer and longer, at some point it's completely obfuscated.
Mm-hmm.
This obviously isn't a great solution because nobody wants to remember a secret that's like longer than the file they're trying to encrypt or whatever.
Right. I mean, that'd be a one-time site.
Yes. So in terms of unencrypting that, because I didn't save the key when I ran it, I won't be able to. But if I were to save that key when I ran it, then I could. So I mean, I could go back over here and before I started using my secret bytes, right? I could just come back. Okay, that's commented out again. Come down here. I have this one. It's going to encrypt it, and then I'll just write another. Copy this again and call it yeah, like a simple and something. And yeah, I'm passing in the exact same thing. So now it's going to create that file and it won't be encrypted. So just to prove that, I'm going to go back, run that again. Going to create all of those. Now let's open.
So you're not loading in the new file,
Wait, what?
You're writing one file that's encrypted, but then you're just writing the second file. You're not passing in the encrypted one.
Right, you have to do.
That's a good point.
You're just double.
Good point. Okay, so the data that I'm technically going to want.
That's what you're writing out, so that would be right.
Yeah, so I'm gonna have to but I'm gonna have to copy pretty much these 3 lines again, so that I can get my encrypted. Or I guess I could just save them. I can just save the encrypted data. So like here's my simple encrypt. So I'm going to just inside of here. I'm just going to say data. Yeah. I don't know. So then right here, I'm just going to say data equals that, and then put that in another paren. So now I should have the encrypted data as long as scoping is right here. Pardon me?
And then on 32, you got to do encrypted data.
Yeah, so then here the data needs to be, yeah, so assuming that that actually worked, doesn't really matter, but assuming that saves it there, which I think it will, then it will decrypt it. Cool, looks like it works. So open Ruby simple on. Okay, so pretty much we're not probably going to walk away from this and use that encryption method. However, if you didn't have access to any other one and you needed one really quick, it's better than nothing. So let's go back over here and just take this code right here and put it up here by the simple encryption method. So this is an actual encryption method. Let me just come back over here, copy that one. Okay, and I can just close that. Also, here actually what I'm going to do, just so I can leave this and commit it and you guys can all see this too. I'm going to take this encryption right here. Man. And I'm going to put it up here. And okay, yeah, and then I'll just write the encryption data to that. And then that's a lot easier to read. Yeah, that's what we should do. And then, so then let's look at this one right here. So we have def encrypt. I'm just defaulting it to like a good encryption method, which is AES 256 CBC. We'll talk about what that is later. But then I'm passing in a secret that isn't so great, but it doesn't necessarily matter in this case. And it works better for what I'm demonstrating. Then I'm creating a cipher with OpenSSL cipher. This would be almost identical to Ruby because I mean it's C library is wrapping OpenSSL for both of them. And so then we have a cipher.encrypt, which in that case is honestly telling this cipher that we just created, put yourself in encrypt mode, which is again a weird C library thing. And here we have like cipher.key. I'm telling it the key is a secret that was just passed in. If it's not 32 bytes long, then just pad it with the numbers 0 through 232 right now, which, yeah, is fine. And I'm not suggesting that like you should just, you know, do that in real life, but for this, it works great. So now we have a cipher.random initialization vector. What that's doing is creating a random 32-byte segment, which is called an initialization vector. The reason that initialization vectors are used is so that every time you do an encryption with the same key, it's not going to result in a byte sequence that looks the same. There's a lot of reasons that is done. For instance, even with like OpenSSL, you know, for instance, like an HTTP header is going to be formatted in this format every time, at least the beginning of it. So if you knew that, you could watch somebody's SSL traffic coming through consistently, and after enough time, you might be able to figure out what is the key they're encrypting this with, given these are the first few bytes, and this is what I expect that data to be. I mean, outside of HTTP, there's a lot of other ramifications for that as well. So I mean, that's a simple reason for the initialization vector is it makes it adds another layer so that like you can't necessarily guess the secret. Then we take that initialization vector, we create a new IO, which is pretty much just memory that's storing bytes in this case. But I mean, I/O is what pretty much everything in a Linux or Unix file system is using to handle everything from hardware connections to your sound card to HTTP connections to TCP/IP.
Same as the industry.
Any sort of socket or file is technically a file descriptor. So what I'm just creating a I/O memory to store this data. I'm writing to that by calling cipher update, passing the value in, whatever the data of that is. I'm writing to this I/O. I am then taking the encrypted data and I'm writing the cipher.final, which is the last 32 bytes, which also contains padding if it's not long enough. And then at the end of that, I'm just returning the bytes of that. And in the case that I wanted to decrypt this, I would also need to save the initialization vector. The point of this talk isn't really about decrypting it though, so I'm not saving the initialization vector. One way that that's commonly saved is base 64 encode these bytes, and then base 64 encode the initialization vector and put it on the end. Another way that I prefer is just take those 32 bytes, add them onto the end of this, write them onto the end of the data before turning it into bytes, and then just know that the last 32 bytes is your initialization vector and pull it off. That takes up less space. This is also very similar to what Rails is doing for encrypting your session. All that, like in that case, you need to have the initialization vector so that you can decrypt it on this end. And they are using a CBC 256 AES encryption on that. Okay, so let's actually come down here and use this. The first one we're going to use, which is similar to Blowfish, but a little bit upgraded from just Blowfish 1, is called ECB, which a lot of people refer to as like electronic cookbook. It's not very secure. So I'm just going to encrypt something with that really fast, and we will demonstrate that. Same one. So this is an encryption method that is actually commonly used in SSL today. It's one of the ones that is slightly frowned upon, but in order to support older browsers, it's still in use. So, you know, this is the reason why we want to get away from those as soon as possible. The next one I'm going to talk about is actually a really good one, that CBC one I was referencing.
So you mentioned that in that one, we had a short encryption password, and you said that that didn't matter, like we had a longer one.
Well, okay, so the longest encryption password it's going to even allow you to use is 32.
Okay.
Which he's hitting every time. He's just filling it.
Which I'm filling up with random numbers. Not even random, actually. In this case, it's like 1 through like something. So like I'm still actually passing that in. I just didn't want to write a string that was exactly that amount of numbers. Okay. I mean, I guess I could have easily just generated like random characters and shown them, but it wouldn't have looked as cool as a text password. So, and that's also a way that you could allow someone to choose like an encryption key or a password that was less than the actual bytes. Like for instance, in the case of like, you know, online, you want to encrypt someone's data and you want them to give you a key to do so, but you don't necessarily want them to require them to type in exactly 32 characters or something. Okay, yeah. So then
the difference in like the noise was interesting. There was always something different was happening, even though the picture is still relatively clear, like the ECB versus the original simple.
Yes, and let me.
A lot of different, but the artifacting is very different.
Yes, you can still kind of make out where the lines are.
Yeah, I'm not saying it's not like less.
Yeah, let me.
That this comes from the same
yeah, let me demonstrate one more thing. So like the Ruby one isn't probably the best one. Let's just do like the Superman one. The Superman one is like more clean cut. Okay, open Superman ECB. So with that one, like, I mean, this is a high resolution image as well. So you notice like where it actually overlaps, because it's like swapping a lot of the bytes. So where it overlaps, when it's closer to the edge, you still actually see a fairly clearly defined line, but technically this whole thing is black. But because of the fact that it's like zoring the left side to the right side as an additional step to obscure it, you're getting this kind of fuzziness along the line, but then inside of it, it's still actually really consistent. So what ECB is actually doing with that initialization vector is you take one initialization vector, and after you XOR the key against the block, you XOR the initialization vector across the block. But they use the same initialization vector and key for every block. So you're still coming up with like a fairly consistent pattern, minus a couple other like things that they added to obscure it. So then if we come over to this one right here, and this is one that actually you should be using. So this one, let's just call this CBC, which is chained blockchain. And it was made way before blockchaining was like running the world. But okay, so now we have AES CBC. And so what this is actually doing is the encryption method underneath here is actually very similar. But the only difference is what it's doing with the initialization vector. And that is, it XORs the initialization vector across the first block, and then it takes the output of that and XORs that against the second block, and takes the output of that and XORs it against the third block all the way to the end.
So you're still able to say, like, keep one ID, but
yes,
it is mutating itself.
Yeah, so you don't, yeah, as it chains down. So you only still need to know what the initial one was, but you can only encrypt it in one direction. Like whereas like ECB, you could actually decrypt really like, as long as you knew how many bytes in you were and you could do your modulus map on that, you could pretty much start encrypting or decrypting that anywhere. Or decrypt it in reverse if you wanted to. Whereas like this one, you actually have to start from exactly one location, which makes it a tiny bit slower, especially with like multi-core systems. But it is a very commonly used one because it is secure and it's a lot faster than some other methods. So let's actually run that one really fast. I just deal with the Superman one again, even though this is already made up. And yeah, so open Superman, and then CBC. So yeah, you may notice that you can't tell what it is.
Did you cross your eyes?
Yeah, there is definitely a hidden image there, like, but
I see it as a kid. You have to tilt them to try to see the image.
yeah.
You said it's a sailboat?
Yeah, that was a deep reference. Not sure. It's a schooner. Not a sailboat.
Yeah, I think honestly, if you look really closely, you can see Paul McCartney. But anyway, you will notice that like there is no recognizable pattern here. There shouldn't be a recognizable pattern there. And this is actually one of the like highly recommended ones to use for OpenSSL right now, and also the one that Rails is using for encrypting your sessions. One other one that I will talk about, which is a branch of CBC. It's very similar to CBC, but it's made to optimize multi-core processing. So it actually kind of starts at multiple places when it's encrypting and decrypting. So it still should be just as obfuscated, but it does actually allow you to start at multiple places within the image for encryption and decryption, which makes it substantially faster if you have a lot of cores. And let me go back over here. And so this one right here is called CPR. Really popular here in the Valley.
CG.
And okay, yeah, let's go back and run that. And then open Superman underscore CTR. And again, there should be no obvious patterns.
Can you, I know that it doesn't matter, but can you put the two side by
I was
side?
gonna ask
Yeah,
you.
that would be great, yeah.
I'm just kidding.
I,
They still
I
obviously
actually-
both work, but I,
Can you superimpose them like they do on CSI?
And then like, yeah.
Yeah.
That one's redder. that
And then
one's
like
greener.
using Visual Basic, like,
Yeah, he needs two people, but he needs somebody else to be on the keyboard
I
at
want
the
to see
same
the
time.
DNA match.
yeah, you see that both types.
And you both gotta get two people on the same keyboard.
can
Yeah,
you,
but typing with both hands.
can you do one with GCM? AES 256 GCM.
Yeah, let me try that.
Should
This
be
is
available.
cool. I gotta split, Isaac. Thanks for doing this.
I'm posting this. This actually already is posted on GitHub, but I'll post any changes I made as well, like that, what you were asking. So yeah, good seeing you, and I'll get some people signed up, including myself. So yeah.
Do you want?
Okay, yeah. Let me try that really fast.
That's something that we use.
It's
Right, say.
yeah.
Oh.
I want to see.
I wanna see how we act.
It's not bad. Like the camera.
But you said G
GCM.
GCM. Okay, and I know like on my Linux computer, I seem to have like 5 times the amount of ciphers that my OpenSSL had from Brew.
Hoping.
So if you didn't have to do anything special to get that, then it will work. So yeah, let's
Change the CDR.
test it.
File.
Oh yeah, sorry man. Good idea. This is why pair programming with like a whole crowd is fantastic.
Two lines up, you might want to change that underscore out of that one.
Yeah. Cool. So then let's go back and encrypt it again. Cross your fingers. There we go.
Obviously found it.
And,
It's so clear. I'm gonna get real sad.
no, that's actually not
Oh,
bad.
okay.
Whoa.
You're saying, yes.
You were gonna cry if it came back with a pattern?
Yeah.
Yeah, I mean, I think that's about, yeah, I'd say I can't tell if that's any worse or better than the others. So
I would.
I think it's way better than the other two, right, Matt?
Gary,
I need to go. I need to go
they
look
can
into
see
this.
the image
I
in
need
any
to.
one of those
Right
three.
now, it like piqued my curiosity.
feel free to like use that code as a starting point.
Well, I'm more about like how you were talking about the what you knew about like why someone would choose this over that because of like multi-processing. I'm curious like what GCM is to CTR to CPC.
Yeah.
Honestly, like
Like there's a lot of families other than AES as well. I chose AES just so I could kind of demonstrate the same thing with different initialization vector patterns. But
I hunted on this stuff like always. I've always just been like, just trust. But I'm not curious.
yeah, I've generally done that as well. But like now I'm having to work with like Bosch and Continental all the time.